Hello and good morning, Doctor. How are you doing today?
Good, thank you. How are you?
Absolutely fantastic. Boy, you are on an adventure right now, aren't you? You're creating with a lot of people on the outside.
Doing my best.
But doesn't that make what you're doing like something that's tangible? In other words, it makes it all so real to you.
Yeah, absolutely. I agree with that. I think it's important to always think about the connections, right? Like, how does one thing affect another? And that's a key here.
And reaching other people, using others to get to other people who didn't know what it is that you've been doing.
Yeah, absolutely. Absolutely. I think especially, it's so important to link things like the arts communities with the science communities, et cetera, because the more you can get the word out, the more information people have, the better it is.
So these communities that you hook up with, are they all working together side by side, or do they have their own interpretation?
I'm going to come clean here. I have no idea what you're talking about.
Okay, what happens is that, radio people versus television people, there's always going to be a difference and a different interpretation. So when you bring the art world and the science world together, those are two completely different imaginations.
Yes. So you'd like me to talk about that? Okay.
I would, because how did you even get into the art world? Because, I mean, even as a writer, the only reason why my art became big was because of the writing that I put on the canvas. And so I understand the differences between the energies.
Coming to this as a scientist, I think one of the most fascinating things is actually how similar the processes of a scientist are to the processes of an artist, right? We basically, it's a very technical subject. You basically get it absorbed completely in a work. You're trying new things. You're trying to solve some sort of issue or create something new. And you can lose yourself in time by doing that, right? And then when you're done with that process, you have something completely brand new for the universe. And I think those processes are incredibly similar. And so I feel that art is, in that sense, is a very apt medium to bring science to the fray. So the fact that in this collaboration between artists and scientists in my book, it's really great to see the actual science displayed in the art, but also to know the connections at the making level. Let's call it that.
Yeah, I love the way that you talk about the universe, because I've always said that to other creative people. Get it out, because none of it belongs to you. It belongs to the universe. So I'm so happy that you brought that up.
Yeah, I love the way you frame that.
Yeah. So what's really interesting here is that the telescope photographs, why does it always look so peaceful? But I bet the truth is, I mean, you've got volcanoes, ice volcanoes, storms with winds at 1,000 miles per hour, but through those photos, we never see anything like that.
Oh, it's true, right? Everything looks so peaceful when it's far away and when you don't have sound, I think.
Yeah.
But as soon as you can kind of bring that environment to a room, and maybe that's something to think about for a future scenario, is the sounds of planets or something like that, right? It really is. Creation is a violent process out there in the universe, and you've got, rocks smashing together to make bigger and bigger rocks to eventually form planets. It's just really amazing. And even the processes on planets, right? You got these volcanoes, these ice volcanoes on Europa. You've got real kind of rock volcanoes, lava volcanoes on the moon Io, which is also circling Jupiter, right? There's a lot of violent processes occurring out there, and sometimes we can capture amazing images of them with spacecraft that go by as well. So that's exciting.
See, you're right about that when it comes to sound, because I do have a pair of VR goggles, and I do go on there and look at what's going on up there on Mars, and it makes you feel like you're there, but there is no sound. Oh, you're so right about that.
Yeah. And it's actually interesting. The InSight mission, which is a mission that went to Mars and landed on the surface of Mars and put a seismometer on the surface of Mars, actually was able to record sound vibrations, because seismometers essentially just record vibrations, and that's what sound is. And so you can actually listen to Mars if you go to the InSight web pages, and if you Google something like sounds of Mars, you will be able to hear the winds on Mars. It's quite interesting.
Yeah, but in a really weird way, doesn't silence hurt? Because, I mean, it would be wind, but there would be no traffic, there would be no human voices, no music. I think that would be scary.
I don't know. It sounds kind of comforting to me. Now I want to go try that out somewhere.
Do most people on this planet know how lucky they are to be here?
Oh gosh, I wish they did. I don't know if they do. I can't speak for other people, but gosh, I wish they did. It is such an amazingly habitable place here on the surface of the earth, right? We've got the right temperatures to be somewhat comfortable most of the time. We've got liquid water on the surface of the Earth, which tends to be really important for, our survival and the creation and growth of life. You've got breathable air, right? All of that is happening on Earth, and that's not happening anywhere else out there that we know of yet.
I just recently did a podcast episode about the importance of tree roots, and I said it's protecting humans from going deeper into the planet where everything is hot, and I believe that they serve as a guard. Do you believe tree roots serve like that, or is it all about the tree?
Oh, gosh. Well, I definitely think that tree roots are incredibly important. I wouldn't say that they serve as a guard to stop us from going inside the planet, but when you think about the ecosystems that occur even with tree roots, right, and how they feed their surroundings and their connections to, say, microbial networks and fungal networks and all of that stuff, right, there's an entire ecosystem or life system happening under the ground. And I think that is absolutely supporting everything that's happening on the surface of the Earth. So in that sense, what's happening underneath is definitely supporting the surface.
Something kind of strange has been happening over the past 3 to 4 months, and that is, why are we seeing the northern lights here in the South? I'm a Montanan. We used to see them up there, but why are we seeing them down here?
Great question. So I actually grew up in northern Ontario in Canada.
Oh,
so
wow.
Although I didn't see them frequently, I did see them once in a while growing up. But the reason they're happening right now is it turns out that you get more northern lights when you have more activity from the sun, when the sun has more sunspots and more solar flares and stuff like that. And the number of solar flares actually is cyclical, and it goes with the sunspot cycle. So we happen to be going into what's called solar maximum. We kind of entered that this year. So this is going to be a time of stronger solar activity, which means more solar flares and more high energy particles getting blasted off the sun and heading towards us. And when those particles travel along magnetic field lines, they can interact with our atmosphere. And so there's more of that happening, which means that sometimes kind of our magnetic shield that protects us, it can't fully protect us, and it gets kind of broken down at lower latitudes, which is why you're sometimes seeing them in Montana.
Wow. How is it that science can see beneath the surface of the planet without digging into the planet?
Yeah, great question. So we're very much, when we do science to study the interior of planets, we are very much acting kind of like what doctors do when they're trying to figure out what's wrong with you, right? Hopefully their first instinct isn't let's dig in there and figure out what's causing that ache. Instead, it's things like we're going to do scans, right? We're going to do CAT scans, we're going to do x-rays, stuff like that. And that's exactly what we can do with the interior of the Earth. We can use fields like gravity fields, electromagnetic fields. We can use seismology, wave fields, to study what the material is like inside the Earth.
Is AI technology getting in there and changing a few things?
Oh, absolutely. I think many scientists in the earth sciences have been using data science, AI technology since its inception, essentially, to study study planets and study how our environment works. So anytime you're using lots of data, and we collect lots of data from satellites and from instrumentation all over the place, and anytime you're creating models, so you're using the laws of physics or chemistry to try and explain what's going on, you're going to be doing data science, using machine learning algorithms and so forth. So yeah, absolutely.
Yeah, I see the planet Earth as being the most beautiful planet out there in the solar system. But why is it the cute little kid named Venus is a problem child?
Oh, Venus is the worst planet in the solar system. I'm just going to put that out there, okay? No, really, it's lovely. But here's the thing. When we're trying to understand the interiors of planets, we have to work really hard to get information, right? Just as I said, we can't just dig down. We have to use all these fancy techniques that we very cleverly thought of years ago or recently. And then you go and you try to apply that to other planets, right? And anywhere you go, you're in good shape until you get to Venus.
Wow.
Venus just does not want us to learn about its insides. And I'll give you a couple of examples. So, for example, one way we learn about the interior of a planet is to look at how much of a bulge it creates because of its spin. So the Earth is fatter around the center than it is at the poles. And how bulgy it is directly related to what the mass distribution is like inside. So we look at Earth's spin, we look at how bulgy it is, and we can tell something about the interior. You go to other planets, you can do this too. But you go to Venus, and Venus is rotating so slowly that it basically has no bulge, and you can't do this.
Oh, my God.
Then you say, okay, well, let's use seismology, right? And we've done seismology on Earth, waves traveling through the Earth, seismic waves. We can use the speeds of those waves to figure out the material inside. And we've learned so much about the interior of the Earth from, where do volcanoes originate and where do pieces of the surface of the Earth when they're subducting back into the Earth at subduction zones. Where do they go? We could see all of that. We've also done seismology on the Moon and on Mars.
Wow.
But if you try to go to Venus, you got to land a seismometer on the surface of Venus. The pressure is extreme. You've got horribly sulfuric acid environment that will just basically corrode your instrumentation immediately. So sorry, no seismology on Venus at the moment.
Oh my God.
So just anywhere you try to do anything on Venus, just Venus is like, I do not want you to learn about my insides whatsoever. Stay away.
I love that ego. I love that ego. Where can people go to find out more about you, Doctor?
So first of all, I highly recommend my book that came out in November. It's called What's Hidden Inside Planets.
Yes.
You can find it at your local bookstores or on any of your online retailers. You can also get it at Johns Hopkins University Press with a discount code. And I'm on Blue Sky. If people are on social media, as Planet Sabine there, and I'll be posting things on there as well.
I love it. Please come back to the show anytime in the future. The door is always going to be open for you.
Oh, thank you so much. I appreciate that. This was fun.
You be brilliant, okay?
Thank you. So, same to you.